Okay, so now we're going to talk about falling and tossed objects. We're still going to use the basic kinematic equations. However, there are some important concepts we need to know. First, we have to make sure and designate what is positive and what is negative. Typically for falling objects, even tossed objects too, we say downward, anything pointing down is the positive. Anything going up is a negative. So with that being said, and we also need to know certain, constants. So with that being said, let's go ahead and do like we normally do. Let's write out all our variables. First, since we're talking about vertical motion, we're going to use y instead of x. It says Brian throws a freshman downward from a bridge at 15 meters per second. Before I get any further, it's important that it says he throws the freshman 15 meters per second. If it would have said dropped, then usually if you drop something, there is no initial velocity. But since you're actually throwing something, there is an initial velocity of 15 meters per second. So Brian throws a freshman downward from a bridge at 15 meters per second, presumably his brother. How fast will it be moving just as it strikes the water 75 meters below? So since we're talking about vertical motion, we'll use y's. Why not? In this case, will be 0. And again, it's just like x naught. 99.9% of the time, it's going to be a 0. YF is 75 meters. And again, we're using positive because we're going down. So we're starting up high. Sometimes it helps to draw a picture. So let's say, oh, we're on a bridge. There's Brian. And he throws this freshman downward. And there's the water below. So from here to here is 75 meters. Not showing up too well. That's a 75, trust me. Next, we'll do our velocities. V naught is 15 meters per second. VF is what we're looking for. We're looking at how fast is this freshman going just as it strikes the water. One of the misconceptions is, okay, when you throw something down and it hits the ground, how fast is it going when it hits the ground? People go, oh, it's 0 because it hit the ground. No, you're looking at the moment just as it hits the ground, not the moment after it hits the ground. Next, I need my acceleration. Now, here is a constant. Whenever we're talking about objects that are falling or objects that we throw up in the air, when it is falling, we say we use 9.8 meters per second squared because that's the rate of acceleration for gravity. Gravity's acceleration is 9.8 meters per second squared. I still use A, but you'll notice in the textbook, they'll use G because it's gravity. Again, I just use A because that's what we're used to. That fly is back. Every video, that fly comes in here. Anyways, now, because I said down and gravity always points down is positive, that's why we use 9.8, positive 9.8. If we were to toss something up in the air, we would use negative 9 point, because you'll notice that when you toss something up in the air, it slows down because gravity's pulling it down. So when we throw something up, when the object goes up, we use negative 9.8. But since the object's falling down, we use positive 9.8. And then the time, we don't have time, they didn't give us time, we don't need time. So now I ask myself, okay, what equation does not have time in it? Well, you should know this one. It is VF squared equals V naught squared plus 2A YF minus Y naught. Just like I've done in all the other videos, go ahead and cross out things that need to be 0. So, in this case, the only thing that's a 0 is the Y naught. So that leaves me with VF squared equals v naught squared plus 2a yf. So y naught was 0. Now, my goal is to solve for vf squared. Well, not just vf squared. My goal is just to find vf. So how do I get vf by itself? Good news is it's already on one side by itself, but it's squared. I got to get rid of that square. How do we get rid of a square? Take the square root. So I'm going to take the square root of both sides. Now I have the equation vf equals the square root of v naught squared plus 2a yf. Now all I need to do is just plug and chug. So that'll be 15 squared plus 2 times 9.8 times 75. Smartboard's not really calibrated, but there you go. Next, if I look at my sig figs, I'll notice it's all 2 sig figs. The 9.8, very important. Even though it says 2 sig figs, 9.8 is a constant. We never worry about the sig figs for 9.8. So, 15 squared plus 2 times 9.8 times 75. Take the square root of that. I get 41.17. But since I want only 2 sig figs, I'm going to round this to 41 meters per second. So that's how fast the freshman hits the water. And there you go. That's falling objects. Not difficult whatsoever. You just need to remember that when it's falling, even though they don't say what the acceleration is, it says that the object's falling. You must know that when things fall, it's 9.8 meters per second squared. And when things are tossed up in the air, it's negative 9.8 meters per second squared. And that's it.